Good morning, my YouTube viewers. It's Crystal here. I'm doing a little bit of a different video this morning than I've been doing for the last couple of weeks. We're doing a video on machine learning with the Kaggle website, and every month Kaggle has a competition, and I try to enter the monthly competitions. So I entered the competition late, and the reason why is because I was working on some things on Excel. But when I finished working on those things on Excel, or not really finished with them, but I reached a good stopping point, then I decided to go ahead and work on Kaggle's machine learning competition. And this month's competition was to predict on the probability that a person will get a loan. And so that's what the competition is. I did it one time. I created my model, and I created my algorithm, and I ran it one time, and I got 93%. And I thought, well, 93% is good enough for me. And the reason why is because I'm busy doing some Excel work, and I need to get back to that. But I have a list of things that I have to do. So this is the algorithm that I developed, and I ran one time, and I got 93% on it. First thing we're going to do is we're going to talk about our problem statement. The problem statement is predict on the probability that a person will get a loan, which was good really, because I've been working on probabilities in Excel. So it was good that I came back here to Kaggle, and I'm working on probabilities again. And so after we've gone through our problem statement, we want to input our libraries. So the libraries we're going to input are going to be NumPy for numerical computations, and NumPy arrays, pandas for data processing, and series and data frames. OS is for the operating system to go out and get the files that are going to be used. SciPy to import the models, scientific models. SciPy is Python's scientific library, which is interesting because I was working on some scientific tests with Excel, and I was working on a scientific test with Python as well. sklearn to provide machine learning functionality, matplotlib to visualize the data, and seaborn to visualize the data as well. So we're going to use OS to go into the operating system and retrieve the files. And we've got 3 files, being train CSV, test CSV, and sample submission CSV. So those are the files that we're going to be working with in this problem. And then what we're going to use is we're going to use pandas to read the files. And so we're going to convert the files into data frames and call them train, test, and submission. So you can see train here. It's got 13 columns of data. The last column of data is the loan status, which is the target. And the rest of the columns of data are pieces of information that's going to determine whether or not a person gets a loan. We check for null values. There are no null values, so that's good. We don't have anything that we need to impute. We look at our test data frame. The test data frame is the same format as the train data frame, with the exception that it doesn't have a target, because that's what we're going to be making predictions on. We check for the null values in the test data frame. There's not any null values, so that's good. That means that we won't have to impute anything. We've got our submission file. The submission file is the file that Kaggle wants to see when we submit our work. So we submit our work in the same manner as the submission file. Now what we want to do is we want to determine if the columns of data come from the same distribution. And so we're going to use the Kolmogorov Smirnov test in SciPy. And it looks here like all of the columns of data are from the same distribution because the PV is greater than 0.05. 0.05 is 5%. So I suppose if I had wanted to, I could have increased the PV to 10% or maybe even 50%, but I kept it at 5%. And the only columns of data that were not from the same distribution were the ID, but that's okay because I was going to drop the ID anyway. The reason why I was going to drop the ID is because Pandas automatically indexes every row of data, so you don't need the ID. But we do know that the ID wasn't from the same distribution. Now what we're going to do is we're going to analyze the target. The target is the loan status in the train column, and then we're going to view that. We're going to make a distribution of that. So you can see that this is our target. You can see you have a lot more zeros than you do ones. That means a lot more people are not going to get a loan than they are going to get a loan. That indicates that this is an imbalanced data set. And because it's an imbalanced data set, you're going to either have to use balancing techniques or you're going to have to use a model that allows you to balance your work. And now that I think about it, I think I might actually balance my weights again and see if I can improve my schedule, improve my score, because yeah, I just think I might do that. See if I can improve my score, balance my class weights. I didn't do that last night because I was doing it in bed and I couldn't see very well. And now what we're going to do is we're going to encode all of the columns of data that are categorical in nature. And in addition to encoding all the columns of data, we have to set it up for handle unknown and use encoded value. And we're going to set the unknown value to -1. So we've encoded all the columns of data that have categorical values in them. We're going to create a heat map. What we're going to do is core equals train.core, and we're going to create a heat map from core. And this is what core does is that sets the correlation between the columns, and you can see the correlation between the columns. And you can see that there's a few columns that have a high correlation, like a loan grade, and a loan int rate and loan grade have a pretty high correlation, and the person's age and the person's credit history length also have a pretty high correlation. But I didn't want to remove any columns of data, but if I had wanted to remove those columns of data, then those would be 2 columns of data that I would think about removing, because you would have to check to see, you would have to do a numerical check to see the columns of data that were highly correlated, and then you could remove any columns of data that are highly correlated. But I didn't do it in this instance because it was only like 11 columns of data that we were using. Now we're going to define our dependent and independent variables. So Y is your target, X is your train, X test is your test data frame. And then we're going to use train test split, and sklearn to split the data up into training and validating sets. Now we're going to define our model. The model that we're going to define is going to be extra trees classifier, and I adjusted the max depth to 30 so I could get 100% on that. Now we check our predictions. You can see we've got a lot of zeros, and then we check the accuracy. The accuracy is 94%. I checked for unique counts on the prediction, and there was 52 10 zeros and 655 ones, and that indicates that the class imbalance was addressed. But I'll show you, I think if there is a class weights on the extra trees classifier, I'm going to go ahead and put the class weights in there, so hopefully I can improve my score. I checked to see how many values, which I've already said, were in the zeros and ones, and we had 52 10 zeros and 655 ones. Now I checked the feature importances to see which features were the most important, and that is an attribute and extra trees classifier and any of the tree-based algorithms, so you can see which features have the highest importance. So you can see loan percent income has the highest importance. Loan grade and loan interest rate, they have high importance. And the personal income has a high importance as well. So that way you can see which features have the highest importance. So if you decide you want to remove a feature, then it's a good idea to use this attribute feature importances, so you'll know which features to actually remove. Now we're going to predict on the test set, and the thing about predicting on the test set is we're also predicting on the probabilities. So pred is the probability, but when you get the probability, it's going to be in two numbers that equal 1, and so I decided to use the number in the first row. And remember, in Python, 0, the starting number is 0, so I didn't use the number in the 0 row, I used the number in the first row, and that gave me my probability. And then what I did was I prepared my submission. So the submission loan status equals pred. Submission to CSV is I created a new CSV file, and the index is false. I'm not going to index it because I don't need to, because in the submission file it's already indexed. Submission.read CSV, so I'm going to read the submission file that I've already made, and this is a submission. And when I submitted my work, I got 93% accuracy. But I think what I'm going to do now is, I was in a hurry last night. I was actually in bed with my laptop, and it's hard for me to see. So I think what I'm going to do now is I'm going to go look on the extra trees classifier, and if it does have a class balance, I'm going to balance the classes and see if I can improve my score. So thank you so much for watching my code review. If you like this video, please like and subscribe, and I look forward to making more videos for you in the future on all subjects technical.